Hello, geometry students. Today we're going to be talking about triangle midsegments. A triangle midsegment is a segment whose endpoints are on the midpoints of two of the sides of a triangle. And here's an example of what that would look like. So DE is the midsegment of triangle ABC. And notice its endpoints are the midpoints of two sides, and notice it doesn't touch the third side of the triangle at all. And if we have a triangle midsegment, here's the big theorem of the day. There are two parts to this theorem. If we have a triangle midsegment, we know that that midsegment is half the length of the third side, the side it doesn't touch, and it's parallel to that third side, the side it doesn't touch. Here's a summary slide if you'd like to take a picture. So pause the video and see if you can use that theorem to answer this question. First thing we do is we know that from the scratch marks, these two being congruent, these congruent scratch marks, we know that R, S, and T are all midpoints. Because of that, we know that the definition of a midsegment kicks in. RS connects two midpoints. So RS is one of the midsegments of triangle DEF. We know ST connects two midpoints, so it's also a midsegment, and RT is also a midsegment of DEF because it also connects two midpoints. So we have three possible midsegments in triangle DEF. The next thing we do is we apply our midsegment theorem. Specifically, we apply the part that states that if it's a midsegment, we know it's going to be parallel to the third side. So RS touches these two sides, so RS is parallel to DF in green. We know midsegment ST touches these two sides. It doesn't touch this side, so we know ST is parallel to DE, purple. And we know midsegment RT touches these two sides, doesn't touch this side, so RT is parallel to this side. RT is parallel to EF. Pause the video and use your triangle midsegment theorem to figure out the answer to this problem, and then press play for the solution. The first thing you'll do is notice that these scratch marks tell us that U and V are midpoints. The next thing we know is because U and V are midpoints, the definition of a triangle midsegment applies. UV is the midsegment of triangle NOM. Then we can apply the triangle midsegment theorem, specifically the part that talks about how a midsegment of a triangle is parallel to the third side. So UV will be parallel to NM. And then we can use all of the properties of parallel lines that we learned previously. Parallel lines cut by a transversal, same side interior angles will be supplementary. So the angle we're looking for is measurement of angle NUV. Call it X, and solve. Pause the video and use the triangle midsegment theorem to find all the missing lengths in this diagram. We're given that B, U, and T are all midpoints, and because of that, we could mark the diagram accordingly, since we know the definition of midpoint means a point that divides a segment into two congruent parts. And so each case, we can write those marks. Now, once we know that, if we know these are equal, and we're given this is 50, we know these have to both be 25. If this whole thing is 40, we know these two things have to be 20. So that we can see right away just based on midpoints. And then we know that the midsegment definition kicks in. Because each of these connects midpoints of the triangle, we know that UT, UB, and TB are all midsegments of triangle QRS. Then we use the triangle midsegment theorem, specifically the part that states that the midsegment of a triangle is half the length of the third side. So if TB is midsegment, parallel to QR and also half as long as QR, if TB is 30, we now know QR must be 60. Pause the video and use the triangle midsegment theorem to solve for x, and then find the length of the midsegment. First thing we'll do is we'll use our definition of midsegment, because we see from these scratch marks that these are both midpoints of their sides, so this is the midsegment. And then we can use the triangle midsegment theorem. Specifically, the part of the theorem that says that a midsegment is half the length of the third side. And we can use that theorem to set up our equation. 3x is going to be half of 4x plus 20. Multiply both sides by 2. Get all your x's on the left and inverse operations to solve. Once we have x, we can plug it in, knowing that we want to find a midsegment length. It's 3x. 3 times 10 is 30. Pause the video. Use your triangle midsegment theorem to answer the questions and find measurement of angle C. We're given D is the midpoint of AB and E is the midpoint of CB. Therefore, the first thing we can do is use the definition of midsegment to know that DE is the midsegment of triangle ABC, because it connects the midpoints of two sides. Next thing we can do is use the triangle midsegment theorem, specifically the part of it that states that if you have a triangle midsegment, then that midsegment is parallel to the third side. And then we can use our properties of parallel lines. Parallel lines cut by a transversal, corresponding angles are congruent. And that is it for triangle midsegments. So I will leave you with this little baby leopard and wish you a great day.